All right, here we are given a rational function, x squared minus 1 over x squared minus 3x minus 4. Yes, 1, 2, 3, 4. We are going to find the vertical asymptote and also the whole of this rational function, if there's any. So let's get to work. First, let's go ahead and find the candidates of these two things. And that is, let's just go ahead and find the domain. So let's go ahead and set the bottom not equal to 0 because that's the restriction whenever we have a rational function, and that's how we find the domain too, right? So we look at x squared minus 3x minus 4 being not equal to 0. Let's go ahead and factor it. We get x minus 4 times x plus 1. And this is not equal to 0. Right here, we know x cannot be equal to 4. And right here, x cannot be equal to negative 1. All right, so this is the restrictions for the function. But these two numbers are the candidates for being a vertical asymptote or a hole on the graph. But which one's which? What we do first is we put the numbers back to the original and see what happens. So let's check when x is equal to 4. Plugging into here, we will get 4 squared minus 1 over, and we get 4 squared minus 3 times 4, and then minus 4. This right here, we get 16 on the top, minus 1, which is 15, over 0 on the bottom. Yeah, so that's pretty much the check for that. And let's also put negative 1 into the original and see what happens. So we get negative 1, I know it's 0 over 0, but eventually it gets all the work, over negative 1 squared minus 3 times negative 1, and then minus 4. Okay, here is 0 on the top, and on the bottom, work that out, we also get 0. All right, so we have two very different behaviors. The first one is a non-zero number over 0. The second one is 0 over 0. So what's the conclusion? This one right here, in fact, we cannot conclude anything yet, but this one, we can actually conclude that we have a vertical asymptote. So right here, I can say we have a vertical asymptote at x equals 4. All right, and then now, let me write down some notes for you guys. For the vertical asymptote, this is a situation that we have a non-zero number on the top over a 0 on the bottom, guaranteed. Whenever you have that, vertical asymptote, when we have that, done. All right, now, what's 0 over 0 though? Well, this right here is technically just a candidate of being a hole of the graph. So let me write this down right here for you guys. In order for us to get a hole, how do we do it? Firstly, we get 0 over 0 from the original, meaning that you don't reduce anything, just from the original, which we did right here, right? Because that's what we did. Well, in fact, this is not enough. You will also have to plug in negative 1 into the reduced version. Whenever you get 0 over 0, in fact, this right here can be reduced. Trust me. Because of the factor to 0, technically. But you can also trust me. All right, let's go back here and factor it cancels things out. Look on the top. We can factor it as the difference of two squares. We get x minus 1 times x plus 1. And then on the bottom, we have x minus 4 times x plus 1. This and that can cancel, and we know this is equal to x minus 1 over x minus 4 under the condition that x is not equal to negative 1. Okay, what we have to do now is to put negative 1 into the reduced version and see what happens. Let's see, we will get negative 1 minus 1 over negative 1 minus 4, and this right here gives us negative 2 on the top over negative 5 on the bottom, which is just a nice number. So in fact, here is the detail. If you get 0 over 0 from the original, and then I will have to say, then no non-zero over 0 from the reduced expression, then you will have a hole on the on the graph. So right here we can draw a conclusion that we have a hole at x equals -1. Whew. Yay, we are done. But maybe some of you guys noticed already, why did I leave a space like this right here, right? Because I want to show you guys this right here real quick, because this kind of things can be extremely tricky. All right, let me demonstrate this idea real quick. All right, so let's consider another function. Let's say g of x, and for this one, let me just tell you, if we have x minus 2 over x squared minus 4x plus 4. Let's go ahead and identify the vertical asymptote and the whole of the graph of this function. And to do so, again, we are just going to look for the candidates first, and that's to find the domain first. So let's pay attention to the denominator not being equal to 0. So x squared minus 4x plus 4, put it not equal to 0. Factor it, we get x minus 2 times x minus 2, which is x minus 2 squared, not equal to 0. This means x cannot be equal to 2. And this right here will tell us the candidate for the vertical asymptote or the whole. But which one switch? Let's go ahead and do what we did. First, plugging 2 into the original. So we are going to get 2 minus 2 over 2 squared minus 4 times 2, and then minus, plus 4. For this one, on the top we get 0, on the bottom we also get 0. So what do we get? Is this a hole on the graph at x equals 2? No. No. Why? Because of this. Why? Because it's tricky. So be really careful with that. When you get 0 over 0, when you plug into the original, it's just a candidate, all right, being a hole on the graph. Now, look at this. We can factor it. On the top is just x minus 2. On the bottom, we get x minus 2 squared, which is x minus 2 times x minus 2. Well, you see that we can cancel one of these. And in fact, we get 1 on the top over x minus 2. And again, that's denote that x cannot be equal to 2. Now, if we put 2 into the reduced version, what do we get? We get 1 over 2 minus 2, which is 1 over 0. If you still end up with a non-zero number over 0 from the reduced expression, in fact, you will end up with a vertical asymptote. Right? You end up with a vertical asymptote still. So for this situation, we will have a vertical asymptote at x equals 2. Alright? So be really careful. I know it's tricky. I know it's hard. Together we can do it, just with some practice with it. Yeah? Let me know if you guys have any questions. I'll be happy to make more videos for you guys with similar questions. But hopefully this right here is clear. That's it.